All right, I think it's time to start. Good afternoon, everybody. My name is Julien, and I work for AWS, and we're going to talk about backends. And although the title of this session is referring to Java, what I'm going to tell you could really apply to any other language, but the code examples that I'm going to use are based on Java. Okay, so just a few words about me really quick. I've been using Java for as long as I remember. Sometimes I wish I did not remember. I actually started working with the first versions of Java, and I was doing embedded development at the time. So I could tell you some horror stories about embedded Java in 1999, but we'll skip that. And generally, one day I love Java, and the next I swear I'm never going to write a single line of that language again. But hey, it's still very popular, and it gets the job done. So why not? I'm traveling all over the world basically to meet you guys, developers, engineers, sysadmins, etc. That's pretty cool. It's my first time in Riga, so definitely enjoying it. And prior to that, I spent my life building stuff, scaling stuff, fixing stuff, and fixing people sometimes. Okay, we don't care. So what is this about? So first, let's take a few seconds to talk about how you actually build Java apps on AWS. Then quickly we'll jump into the core of the discussion, which is what are my databases options? So we'll talk about RDS and DynamoDB. And we'll talk about analytics as well, because more and more, those two lines are kind of blurring. Where does the database stop and where does analytics start? And so we'll talk about EMR and Hive specifically. We'll talk about Athena, and we'll talk about Redshift. And of course, we'll try to sum things up and give you guys some solid advice, some real life advice on what to choose. All the code that I'm using is available on GitHub. Right, so if anybody finds a bug, send me a pull request. You might win a sticker or something. Okay, so let's talk about building Java apps. There will be some time at the end of the session for questions, but as a general rule, if you have a question that's really, bugging you right away, please raise your hand. I don't mind. Okay. Try to keep it short, and then we can go and have beers and talk about Java for hours after the session. So when you build stuff on AWS, you always have 4 deployment options. Okay, so you have the classic one, which is deploying to EC2, to virtual machines. Anyone using EC2? All right, thanks. But most likely you're spending too much money. But I'll give you some better options. Option number 2 is using Docker containers within ECS. Anybody using ECS? All right, do you like it? Yeah, kind of. Okay. Yeah. Third option is Lambda, building serverless apps. Anyone is doing that? All right. Well, anywhere I go, people use Lambda, so it's a worldwide epidemic now. Good. You can only use Java 8 for Lambda, and I'm guessing you don't use the AWS CLI. Probably you're using some of those frameworks, serverless or Gordon or Apex. Is that what you're using? No? Okay, we can talk about that later. And the last option is to use the platform as a service way, and that means Elastic Beanstalk. Anyone using that? Okay, we need to talk. What do you mean it's not working? Come on, it is. And it's probably the simplest way to deploy anything on AWS because you don't have to manage the infrastructure. You just zip your code and push it to a pre-built environment, and it just works. And you can do all versions of Java and quite a few containers too, okay? Of course, we have a Java SDK that still works with 1.6 if you're stuck with that. And it's available on GitHub, of course. If you're using Eclipse, we have an AWS plugin. I'm guessing 99% of you are using IntelliJ when you do Java stuff, right? But hey, I'm an older guy, so I use Eclipse. I keep the legend alive. And we have a pretty nice plugin that is actually maintained by AWS, and that allows you obviously to build projects, deploy stuff in one click, and also browse quite a few AWS resources. I'll use that today. I can quickly show it to you. So in the spirit of being a modern guy, I looked for AWS plugins on IntelliJ. So I did find a Beanstalk plugin. And none of these are maintained by AWS. They're all third-party. There's a CloudFormation plugin to help build your infrastructure templates. And there's an AWS Manager plugin, which is similar to the one for Eclipse, that allows you to see your resources, but it's very old. It's not maintained anymore, and sources are not available. So hopefully the initial developer will post the sources and people will resurrect it. But today, I would not recommend it. A very quick reminder on credentials, because security is an obsession for AWS, and honestly it should be an obsession for everyone. So permissions and roles and credentials are managed in a service called IAM, Identity and Access Management, right? So that's the first place to start. When you create users, and they could be human users or they could be applications, you need to create an access key and a secret key. And using those keys, you will authenticate, and maybe you will have permissions to use AWS resources. I say maybe because the default setting is everything is forbidden, right? Which is, in my opinion, the best default setting for security. So when you create a user, when you create keys for an application, by default, nothing is allowed. And you have to explicitly allow this API to be invoked and this resource to be accessed. So it's a bit of work, but it's the most secure way to do things. Okay, and so permissions are defined in policies, and you can attach policies to groups or users for people. And for applications, you will attach them to roles, and then you will attach the role to an EC2 instance or a Lambda function or a Docker container, and that will give it the permission to access this API and that resource. Okay? If you've worked with AWS before, you're familiar with this. I have to remind you, please do not hard-code secrets in your apps. I still see this, and it's really bad. It's a bad practice on AWS. It's bad practice everywhere. Passwords in code, API keys in code. It's a nightmare. Do not store them on EC2 instances, because if one of your instances gets compromised, then much more than your instance could actually be compromised, right? So trust me, there is no reason to do it. Never, even in development. It will always end in tears. You will end up committing your secret keys to GitHub, and that's something that we monitor. And you will get a friendly email from AWS support saying, guess what? We suspended your account because we found your keys on GitHub. So please send us an email or please call us, and we'll resume your account. So it's always unpleasant, but it's better to do this than to let your account be used by millions of developers on GitHub who are very keen on enjoying free AWS resources, right, on your behalf. So when you're using applications, you must use roles, right? When you create an instance, when you create a Lambda function, when you create a container, you must assign a role to it. And that role will have permissions, okay? And this will give permission to the service to actually access the resources that it needs, okay? And for backend credentials like user, logins, and password for MySQL or Redshift, and that's what I'm going to show you. That's what I'm going to do today. You can use a sub-service of EC2, which is called a parameter store. So it's a secure store where you can put all your credentials and have them encrypted automatically by KMS, which is our key management service. And basically, you can just put it there and get it securely when you need to. And that's what I'm using. Okay, so please no hard-coded secrets. So this is the reference architecture for, I would say, backend. I try to keep it simple. I will not talk about all of these today. And so the first layer is really about data stores, like RDS and DynamoDB. And of course, we have some other ones, but you could not really call them databases, right? Like Cloud Search or S3. They're cool, but they're not databases. And then we have analytics. And a good choice to perform analytics could be Amazon EMR, Hive, and so on, Redshift, or Athena. Okay, and these are the 5 we're going to look at today. Okay, so let's start with databases. The first one is, I would say, the obvious one. The first one usually that people look at. It's called Amazon RDS, and the name is pretty obvious. It's a managed service for relational databases. So what does it mean to manage service? It means you don't have to create, scale, or fix infrastructure, right? We do that, okay? So you basically launch an instance using one of the engines that I'm going to mention in a second. You pick an instance size, you decide whether you want high availability or not. You can always add it later if you want. You wait for a few minutes and your server pre-installed with your database engine is ready, right? So you can scale up and down and you can shut them down when you don't need them anymore. So it's pretty cost effective. And there's a 99.95 SLA on it, which I'm happy to say we tend to exceed. So the engines that are available on RDS are, so I'll talk about the ones you know, probably. So MySQL, MariaDB, Postgres. And this is the slide that is never up to date. It's probably outdated today. I checked it yesterday. I wouldn't be surprised if something had changed in here. Quite recently, we still supported MySQL 5.1, if you can believe that. So it changes every day. And for commercial databases, we support Oracle and SQL Server in way too many versions that that doesn't even fit on this slide. So the last one that we support is called Aurora. Anyone has heard about Aurora? Okay, a few people. So Aurora is a high-performance implementation of MySQL and now Postgres. So basically, our teams took MySQL and Postgres and injected the AWS secret sauce into those to make them 5 to 10 times faster, to improve high availability and to improve scalability. Aurora can scale storage automatically up to 64 terabytes. Okay, so you could have a 64 terabyte relational database. I don't believe it's an actual good idea to do that, but hey, whatever floats your boat, right? There's a very cool research paper that just came out a few days ago on the design principle of Aurora. If you want to read it, it's very nice, good reading. Okay, so you can pick one of those. So who uses RDS? Well, like I said, show me an application that doesn't need a relational database. So it's one of our most popular products. I could just pick one here, which is Airbnb. Everyone knows those guys. So Airbnb is using RDS for pretty much all their backends. And that's pretty spectacular given the scale of Airbnb. And very early on they picked RDS and they just stuck with it because it just scaled and it allowed them to focus on building the service, building the application, building the product, not doing DBA stuff, right? So I would say it worked pretty well for them. Rovio is another company that scaled pretty well. And if you have a Lamborghini, I wish you have one. I wish I had one. Then they're using RDS too. I'm not sure what for, but they are. Okay, so everybody's using databases, and RDS is a very popular choice because it makes your life simpler. You focus on building the product and not on tweaking your database. So let's look at an example. So on each of those slides that you will see, there's a link to the SDK for the service, right? How to create a cluster, how to scale it, etc., etc., and how to install the JDBC driver for those. In this case, I think I'm using the MySQL driver. All right. So, oops, we don't need that. So how do you connect to those guys? Well, I mean, you've seen this one a million times before, right? It's no different. So all these backends except one, no, actually all these backends use JDBC. So I'm using vanilla JDBC code to connect to them. Okay. The only difference is some of them need a user and a password, and some of them just need AWS credentials. like a role, but that's the only difference. Okay? And the query I'm running, so I loaded the same data set on all backends, except for DynamoDB. So it's 1 billion lines of fake e-commerce transactions. They're not AWS transactions or Amazon transactions. I did not steal any logs. Okay, so it's a billion lines, and I'm just looking for all the people named Jones in Florida or something. Okay, simple way to do that. So here's how you would connect to Aurora. Do I have the laser? Okay, so that's my driver. As you can see, I'm using MySQL here, the MySQL driver. And that's my endpoint, so the cluster name and the database name. Okay? You've done this a million times. Here, I'm connecting to EC2 to get credentials. So the login is called backend user, and the password is called backend password, so that I don't have to hard code anything in there. And this is how you do it. Okay? You're building a client to that systems manager entity, and you're just sending that get parameter request with the parameter name. Just gives you the value back, and it decrypts it for you. Okay, couldn't be simpler. So please do not hard code stuff. There's really no reason to do it now. Okay, so right there, I'm getting my credentials, okay, and I can connect. So I create an RDS client in the US East 1 region. That's where my cluster lives. I'm going to call one of the Java APIs for RDS to describe that instance I'm connecting to, and then I'm just sending that query, looking for Joneses in Florida. Okay, want to try it? 1 billion lines. Hopefully that's fast. And hopefully that works. Okay, so got my credentials. That's my describe DB instance thing, right? Outputting the name of the instance and the size. So here I have a master and a slave, a read replica. And how many people did I find? 226. Okay. So whoever thinks relational databases are not fast enough, think again. Right. So of course I have the right indexes for this, but how long did it take? 1 second? Right. So let's not jump to the conclusion right away. Okay, so that's Aurora, right? So it's like MySQL, but way faster. So if you can do MySQL, you can do Aurora, right? Just enjoy the speed. Let's look at DynamoDB now. So DynamoDB is a totally different beast. It's a NoSQL database. It's fully managed, even more so than RDS. Here, all we are doing, and as you will see in the code, we're simply creating a table and putting and getting items in the database, right? And that's it. We never worry about anything. We never worry about scaling. We never worry about speed. It's really NoSQL as a service, as you will see. And it's been out there for a while. It's been built by Amazon early on, and then it became an AWS product in 2007. Okay, I'm not sure if you know that blog, allthingsdistributed.com. It's the blog of Werner Vogels, the CTO of Amazon. Obviously, I highly recommend that you read everything he posts, especially the technical articles. And these are pretty nice. So, well, DynamoDB is a very popular service too, and I'm sure you know about Expedia, the travel website. They have crazy traffic, and they use DynamoDB for real-time analytics. So they just push tons of events, actually. As you can see, over 200 million events a day into DynamoDB. And they do real-time analytics on top of that. And the only thing you have to do, once again, is creating a table, and that's pretty much it, right? No infrastructure to manage. You can scale that thing way, to the sky and not worry about it. It's just one setting. So always the same story about us. focus on building your business, focus on building your product, leave the plumbing to us, right? We're the plumbing guys. So let's look at Dynamo. Okay, so here there's no connection, so to speak, right? I will connect to the there's no instance, right? So I will not connect to an instance. I will just create a table that is called My Favorite Movies Table, and I will write some items into it. So here I'm going to use the real service, but I should mention there's a local version of Dynamo that you can run on your machine. It's in Java, and you can just start it locally and connect to the local endpoint and work on your machine with DynamoDB, right? Which is nice because you can work locally, do all your testing, and then switch to the production service. Okay? So how do we connect? Well, that's how we connect, right? So this time I'm using the Ireland region, EU West 1. I'm creating a table, so this looks scary, but it's not. Java builders. That's the hate part of my love-hate relationship. So table name, key schema. So this table will have a key called name. It's a hash key, so it allows me to shard the items across the DynamoDB nodes. And the attribute is called name, and it's a string, which kind of makes sense for a name, right? So it's a complicated way to say, hey, I need a sharding key, that's a string, and call it name, please. And that's what we call the providence throughput, which says how many reads and how many writes we're going to do per second, right? So actually, these are read units, so it doesn't really mean 1 read per second or 1 write per second, but we don't care today. And so this is how you scale DynamoDB, right? If you need, a million write per second for a day or 2 days, you would go to the API, tweak those parameters. DynamoDB would provision enough hardware for that in, maybe an hour or so, and then you could turn it down when you would be done working. Okay, so here, this is just for testing. So I'm creating the table. If it doesn't exist, I wait for a few seconds for the table to show up. Getting the table name, I will describe the table. I will add some items. So it's a movie table, so let's add some movies, right? Star Wars, Star Trek, Phantom Menace. Anyone here thinks Phantom Menace deserves more than 1 star? Hopefully not. Okay. I would put 0 if I could. Lord of the Rings, which should have 10 stars. Then I'm going to get one of those items. Then I'm going to build a request to find items with 5 stars. Okay? And again, this looks a little bit complicated, but it's really not. So that's the value I'm going to be looking for, 5 stars. I build my scan request, right? So find everything with rating equal to view rating, which is 5 stars, and just do it, right? So let me check that I did delete that table. So that's the manager that I showed you. I can look at my services. So let's run this thing. Oh no, I'm still running. Sorry, let's do that again. Okay, creating the table. So this takes maybe 5-10 seconds because it needs to provision some resources to do that. So let's just wait for 5 to 10 seconds. Come on, DynamoDB. Don't let me down now. All right. I'm describing my table, so I can see my attributes, my key, right? Creation date, blah, 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 blah. Lots of very fascinating stuff. And then I'm putting my 4 movies, right? Result is empty because I didn't ask for a result. I could ask for the old value to be sent back or the actual new value that was written, but here I don't need it. Here I'm searching for that movie Star Wars. That's that blue line over there. And here I'm finding my 2 5-star movies, Lord of the Rings and Star Wars. Okay? So that's it. Like I said, no SQL as a service, zero infrastructure to provision. I did not start anything prior to that. Okay, for Aurora, I started the Aurora cluster, right? And that took 10 minutes or something. For DynamoDB, I did nothing. Okay, I just did what I did now. And so I should be able to see my. I need to refresh it maybe. Okay, so this is way too small, but you can see 4 items. Okay. All right. So if you insist, you could still do Cassandra or MongoDB, but my answer would be why. And yes, I've done that in the past, but I learned from my mistakes. So here's a recap, and I included more of the other on the other backends. So don't worry, we're not going to read all that stuff. These are the two we talked about, right? And as you can see, they're pretty similar. I would say, except for I would say, do you have a schema or don't you have a schema, which is probably the main thing to select, database between relational and NoSQL. You could have a lot of data stored in both. You could request them at fairly high rates, although DynamoDB will go again up to the sky. We had some customers who ran ads, TV ads during the Super Bowl in the US, and they went up to 1 million reads per second on DynamoDB, and no worries. So their website did not go down. Unlike some others. So yeah, Dynamo is really brutal when it comes to requests. And for the rest, I would say, again, it's more going to be, do you have a schema or don't you have a schema, right? And some additional information on the other backends, but you can read that stuff at home. Okay, so let's move on to analytics. And I'm going to start with everyone's favorite, I suppose, EMR. Or maybe not. Anyway, it's the oldest one. And EMR is a managed service for the Hadoop ecosystem. Okay, so we started with Hadoop and Hive and Pig and all the early Hadoop tools. And as time went by, we added Spark and Flink and Presto, and I'm sure some stuff I have never even tried. So again, it's a managed service. So you just create a cluster, you specify how many nodes you want and what are the Hadoop applications that you want. You wait for a bit, and then the cluster is ready, pre-installed. You don't have to go and install Zookeeper and do that stuff manually, right? Has anyone installed Zookeeper manually? Yeah, was it enjoyable? Okay. It wasn't for me either, so that makes it 2 of us. So again, Hadoop cluster ready to fire in, let's say, 10 minutes, okay? And you can resize them and stop them, and it's nicely integrated with S3, for example. So you could keep all your data in S3, load it on the cluster to run it, save it back to S3. You won't have to worry about HDFS. So if you need Hadoop and want to make it simpler, this is the way to go. We have tons of customers using it, of course, but I selected one of the really spectacular ones. So it's not a really sexy company. It's not a startup. It's a regulation agency for financial markets in the US. Actually, it's the largest one. It's called FINRA. So what these guys do is they look at all market trades in the US during the day, and they store everything. And during the night, they run crazy Hadoop and machine learning jobs on that data to find something that looks suspicious, right? Something that's illegal or something that doesn't look quite right. Imagine that. Billions and billions of trades every day, and they have to look for the few things that are probably illegal in there. And then they report it to the SEC, and hopefully the bad guys go to jail. I like to believe it. Maybe they don't. And to do that stuff, obviously, they have to wait for the market to be closed, right? So when the market closes in the afternoon, they fire up the Hadoop clusters, right? And they use up to 10,000 nodes at any given time. Imagine that. If you needed to build it yourself in your data center, right? 10,000 nodes. I don't think so. and they run all the jobs, and they get the results, and then they shut down the clusters, right? So they actually save tens of millions of dollars every year by doing this, versus building a cluster that's running 24/7, except it's only useful maybe a few hours a day. Okay, so just to show you how large you could go with the EMR. So let's look at Hive. All right, my tunnel is still up. That's a good thing. So Hive, where are you? So here, connection is going to be slightly different. I should hide that stuff here. Yeah, better like that. So I'm using the JDBC driver for Hive. But as you can see, I'm connecting locally, okay? Because I've got a tunnel, I've got an SSH tunnel between my machine and the EMR cluster running in the US, I think. And that's how you connect to our Hadoop cluster. You don't log in and password or whatever. So authentication here is done through the tunnel with the SSH key that I attached when I created the cluster. Okay. So let me start it because it's Hive, and then I will explain it. Go. So the first thing I'm doing, oh come on, this is still DynamoDB. Come on. Yeah. Oops. What is going on here? All right, I've got the code down now. No worries, that works too. Okay. So I'm describing the cluster. Okay, again using the Java SDK for EMR, trying to get some information. So that part was pretty fast. Okay, cluster ready, creation time, blah 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 blah. What subnets it's running. Basically everything you would see in AWS console about this cluster. And oh wow, after 30 seconds or something, I did get my result. And it's the same number, and that's reassuring. Okay. All right, so it's the exact same data set. It's the exact same SQL query, right? Aurora, 1 second, 1 node. Hive, I've got 15 nodes here, and it took probably 20 seconds. So again, if you think you have to rush to Hadoop and Hive to get speed out of your application and your backend, please reconsider. Hive was great for a while, but there are better options out there. Okay. Still, as you can see, using it, it's straightforward. You use this. I could have had a single code example pretty much working for all backends, except for the connection credentials here, connection information. So it's just JDBC and it's just running queries, and that's the boring part. The interesting part is, how fast is it, right? And is it what I really need or not? So, sorry Hive, not a fan anymore. I loved you, but it's over now. Right, let's move to Athena. Anybody has heard about Athena? You guys? Yeah, all right, thanks. So Athena is a relatively new service. It was announced at reInvent in last December, so still fairly new. And what can you do with Athena? Well, you can run read-only queries, so you can run selects on data hosts stored in S3. Okay, so you could have petabytes, tens of petabytes of data, log data or anything, application data, sitting in S3, and you can query it directly using Athena, right? You don't have to load anything. You don't have to index anything. You just go. Right? So I love those services, less work. So you don't create any infrastructure, you don't start anything, right? With EMR, you have to start something. With Aurora, you have to start something. With DynamoDB, you have to create an actual table. Here, you don't do anything. Actually, yeah, you have to create an external table, right? Just to map that schema on the data hosted in S3. But it's just running create external table, blah, blah, blah. And that takes 200 milliseconds, and then you can go. Okay, the service is based on an open source project called Presto. If you have heard about this one, it was built by Facebook. So we took that and we made it, an AWS service. So it uses Hive for table creation and basically data definition, and then it uses ANSI SQL for everything else. Okay, so I can use my same SQL queries on Athena. Okay, there are a few exceptions on what is supported compared to Presto, but mostly it's user-defined functions, and that's about it. Okay. So the cool thing about Athena is that it can adapt to a lot of different formats, because your data is going to be in S3, and the last thing you want to do is transform it, right? You want to query it the way it is. So we can do unstructured data, we can do semi-structured data, we can do structured data, and specifically the columnar formats like Parquet or Orc, which are really nice because you're going to get excellent performance out of them. Okay, and that's the one I'm going to use today. I'm going to use Orc, I think. So if you have data in this format in S3, just create a table that lists the column, and you're ready to go. And yeah, make sure you, and you can also use compressed data or partition data, and that's even better because you're going to scan less data. So your queries are going to be even faster and even cheaper, because Athena, the price of Athena depends on how much data you actually scan for the queries. Okay, so if you use columnar formats plus compression plus partitioning, you end up to fractions of pennies, which is nice. We have customers already using it. DataXoo is an ad tech company in the US. So they run real-time bidding, and they have a retargeting platform. And as you may know, if you've worked in those companies or similar companies, this tends to generate a crazy amount of data, because basically what they get here, they get display requests coming from millions of websites all over the world, and then in real time they decide if they want to buy the advertising space and show a banner on those websites. So they get tons of traffic. So they funnel all of it into Kinesis, which is one of our services. It's a very scalable and a high performance message queue. And then they go into their actual crunching machine, and they dump all the results to S3. And from S3, they use it for database. They use Athena for Hadoop analysis and investigation and data science and everything that you could do interactively. And then, of course, they build some reports. And they have that much data coming every day. If you can imagine that, it's crazy. So just drop it in S3 and query it with Athena. No worries. So let's look at Athena. So Athena is slightly different in the sense that it's completely, fully, absolutely managed, and there is no Java SDK for Athena, right? So I cannot call describe table or describe blah blah blah. Okay. So I believe it's probably the only AWS service that doesn't have a Java SDK. But to be honest, you don't really need it. So all we need is a JDBC driver. So let's look at this. Athena. Okay. So the connection to Athena is a bit different. So I am using JDBC here, but just to show you a different example, I could use different types of credentials. Here I decided to show you how to do it using local credentials. So my local AWS credentials stored on my laptop. Okay, and these are just properties that you pass to the JDBC driver. Okay, so that's where my login and that's where my API key and my secret key are. Okay, and I'm pointing to that file credentials provider class to say, hey, please go read my credentials locally. Okay, don't go and look anywhere else. All right, just an example of how you could do that. Another difference, and this one is a bit sad, but I have to point it out, is that as of today, you cannot have prepared statements for Athena. I was kind of disappointed when I found out, but I can blame Presto for it, so that's good. And that's the actual issues the actual issue in Presto, where basically prepared statements are not implemented. So I'm trying to push for our team to do it and contribute it back to Presto, but I'm not sure they are listening today. So it's exactly the same request, and I'm running it on my Parquet table, as you can see. But it's a regular statement. It's not a prepared statement. So that sucks a little bit, right? And the rest is completely identical. So let's run it. So again, I created nothing. That table barely points to stuff in S3. And let's see how we go. 1 billion lines. No infrastructure at all. Come on, Athena, wake up. Yes, thank you. 226. Okay, so 5-6 seconds. Right? So imagine you have billions and billions and billions of lines somewhere, load balancer logs, whatever it is, right? Application logs, and you have that question where, oh, I'm wondering what the result is. And normally what would you do? You would maybe go to your Hadoop cluster or your BI cluster and ingest all those logs, and it would take hours to set up, etc. And only then you could ask the actual question and hopefully get the answer. Here, just create a table that maps to the actual data in S3, ask your question, and you're done, right? So it will take 5 minutes, not hours and hours. So I am madly in love with Athena, I have to say. But there's even better now. So the last one I want to talk about today is called Redshift, and it's been around for a while now. Anybody uses Redshift? All right. Well, you use all of them. Come on. You definitely deserve a sticker. So Redshift is a relational data warehouse. It's based on SQL. It's compatible with a PostgreSQL, so that's good because I hate learning new stuff. It's fully managed. So again, you just like EMR or just like RDS, you just fire up the cluster and you wait for a bit, and you get your connection chain to the cluster. It's massively parallel. You could have a very, very large number of nodes. You could have up to more than 100 nodes if you wanted. So that's a lot. It will scale to multi-petabytes of data. So it's a really big data warehouse, right? We have some customers who go actually that big with it. NTT in Japan, the telco operator, is running multiple Redshift cluster at petabyte scale. So that works well for them. And you can get to very cost-efficient price points. When you talk about data warehouse, usually you compare the cost of how much, you look at how much a terabyte is going to cost per year. And with Redshift, you could go to $1,000, right? So if you have a data warehouse in the office, just look. I'm guessing it's going to be more expensive than that. And actually less than, well, probably a month ago or 6 weeks ago, we extended the service with Redshift Spectrum. And Redshift Spectrum basically gives Redshift Athena-like capabilities. Okay, so now with Redshift, you can also create external tables and query data hosted in S3. But it's a different service. Spectrum is an AWS build, right? It's not based on Presto. So that's the architecture of Redshift. So client applications connecting through standard drivers to the leader node of the cluster, sending the SQL queries. The leader node is going to build the execution plan, optimize the request, break it down into tiny pieces, send each piece to a compute node, right? And each compute node is going to run that part of the request on its local data, right? And then when they're done, they're going to send all the results back to the leader node, and the leader node sends you the result. So that was Redshift. Now, if the table that you're referencing in your query is actually an external table, the query is going to go to Spectrum. Spectrum is a managed fleet of instances, totally different from the Redshift nodes, and they're going to query your data for you, send back the result to the leader node, and you'll get your result. Okay. So we're going to look at that. So Redshift, when it came out, was a an Hive killer, to be honest. We had a lot of customers who had huge data sets, were suffering with Hive, and they moved to Redshift, and you can read that thing. Most of them said, wow, Redshift is 20 to 50 times faster than Hive or competing solutions. And no, I'm not going to mention them today. Okay, so Redshift is very fast. But with Spectrum, it's even faster. So let's do this. So here, well, I need to get the credentials. I'm describing the cluster, and I'm sending my query. You've seen this 5 times already. Let's do it. So, where's my cluster? Come on. Ah, yeah. All right. Let's do it again. It's a little slow. Why? I don't know. Yeah, nah. 226. Yeah. It should be faster. I don't know. Yeah, maybe it's that describe operation that slows us down. But yeah, actually, Redshift is in this case is quite faster than Athena. This isn't a proper benchmark. So, but again, this could scale extremely high. Okay. So if you have a data warehouse already, if you use Redshift already, then you can extend it. Yeah. Oh, okay. That's why. All right. Sorry. Okay, here we go. Okay, that's more like it. All right, that's more like it. Yeah. Okay, so that was faster than Athena. That's what I wanted to show you. Thank you. All right, time to wrap up. So again, a quick comparison on those services. I'll let you read that part. So this is what we looked at. We looked at 2 databases and 3 services for analytics. And as you can see, they have strong points and weaker points maybe for some of them. So you need to find the one that's really good for your application. Okay, and only you can decide that, which is why we provide multiple choices. Right? We build it and you select the one that you like best. The last thing I want to point out is we have a couple of tools to help you migrate your databases to AWS. There's one called the Schema conversion tool, which you install locally on your machine, connect it to your database. Say, okay, here's my Oracle or my MySQL or my SQL Server database, and I want to move it to something else. So look at the schema and do what you can automatically. And whatever you cannot do automatically, please tell me, right? And I will do it manually. But it can get a lot of the schema conversion done automatically, which is nice. And we have a service to do the actual migration. It's called Database Migration Service, where basically you select the source database, destination database, and it works in all combinations. You could go into AWS, you could go outside of AWS, you could stay inside AWS. And you can have pretty much anything as the source and anything as the destination, including now MongoDB and SAP, and it's pretty extensive. And it's going to help you migrate as you go your database from source to destination. So as you can see, you have a lot of different choices. And again, I talked about Java today, but the same SDK would be available for other languages. You can select from many different options. And some of those tools, like MySQL or Postgres or Hive, you know them already. But here, we take away the infrastructure pain. We help you focus on building your app. And we bring high availability and scalability and security and compliance in addition, so that you don't have to build it. Right? These are super important to get right. So again, you can focus on your creativity and your productivity, work on your business, and leave the plumbing and the low-level tasks to us, right? Thank you very much. If you have any questions, I'll be happy to answer. Thank you.
Yeah. 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 Yeah.